wabarakatuh. In the name of Allah, the most compassionate, the most merciful, praise to Allah. Welcome. This is our second lesson in Organic Chemistry 2. We discussed about today's lesson was about preparation of alkanols. In our previous lesson, we have seen what an alkanol is, the general formula, which we said it is CnH2n plus 1OH. Yes. We have learned also how we can name certain alkanols by replacing the E of the corresponding alkane with the suffix ol. For instance, if we have methane, we say the E is replaced with ol, and then it becomes methanol. We also discussed about isomerism, where we said isomerism is the existence of compounds with the same molecular formula but different structural formula. And then we have categorized the isomerism into two, where we have a positional isomerism and a branching isomerism. So today's lesson will be about preparation. How do we prepare alkanols in the laboratory? And all of them, they have got a similar method of preparation, and that is the composition of glucose molecule in the presence of a certain enzyme. That enzyme, it is in the yeast. It's in the yeast. So today, let us write. We shall be discussing about ethanol for an example. Yes, and if we discuss ethanol, the other method is just the other alkanols. They are prepared in a similar way. So preparation of ethanol. That's our topic today. Preparation of ethanol. What do you think? How do you prepare ethanol in the lab? So ethanol can be prepared by decomposition of glucose molecule. Yes, decomposition of glucose molecule in the presence of enzyme. Now, what do we mean by decomposition? Breaking down of sugar molecule, yes, by a certain enzyme. And that enzyme is found in yeast. So the sugar molecules are broken down into ethanol, carbon dioxide, by the enzyme in the yeast. So the sugar molecule, remember, glucose, sugar. They were talking about the sugar molecule, the same, yeah? The sugar molecule is broken down into ethanol, carbon dioxide by the enzyme in the yeast. So when you add a sugar molecule to a yeast now, what will happen? The yeast has an enzyme. That enzyme now will break down the sugar molecule into ethanol and a carbon dioxide. And sometimes heat is also produced. So it's a very easy method, yeah? It's called fermentation process. This is what happens. Glucose, yes, you add yeast you add yeast, and then what will you produce? Yes, ethanol plus carbon 4 oxide, carbon 4 oxide, and also heat is also accompanied. Heat is also accompanied. Now, in the chemical equation, glucose is just sugar. Sugar, we said it is C6H12 or 6 sugar molecule, yeah? Yes. Then when we add yeast, now, the yeast has an enzyme. The yeast has an enzyme. That enzyme, yes, it's called zymase enzyme. So the enzyme that is found in the yeast is called zymase enzyme. That zymase enzyme now, which is found in the yeast now, after adding to the glucose molecule or sugar molecule, it will break down this sugar molecule into ethanol, which is C2H5OH. Yes? Yes? Remember, it's a liquid substance. And then carbon dioxide gas is produced. Carbon dioxide gas is produced. Carbon dioxide gas is produced. And when you balance, yes, we have here 2 and then here 2. So that's all. That's all. Sugar molecule, you add to yeast, and the yeast now has an enzyme. That enzyme will break down, or it will decompose the sugar molecule into the ethanol, and the carbon dioxide gas is produced. How do you test this carbon dioxide? Calcium hydroxide. Yes, calcium hydroxide. So it produces carbon dioxide, produces yes, calcium hydroxide. Yes, that's the lime water. Lime water. You add the lime water. So it produces white precipitate with lime water. White precipitate with lime water. So this process, what is the name of this process? This process is called fermentation. This process is referred to as fermentation. This process is referred to as fermentation. So it's a decomposition of organic substance by microorganism to produce alcohol, carbon dioxide, and heat. So fermentation, let's define fermentation. This is the definition of fermentation. Is the decomposition of organic substance by microorganism. The microorganism that we're talking about here is a yeast. By microorganism to produce alcohol. The alcohol I'm talking about is the ethanol now. Alcohol, carbon dioxide, and heat. Remember I said heat is produced in form of ATP. Heat in form of ATP. Heat in form of ATP. Heat in form of ATP. However, that's right. However, very small amount of ethanol, around 10%, yeah? Not that much, 10% is produced by fermentation process. By fermentation process. So not enough ethanol will be produced by fermentation process. So if you take glucose, you add into yeast. The yeast has an enzyme. It will break down the glucose into ethanol and carbon dioxide, and heat in form of ATP is produced. But you're told very small amount of ethanol, that's around roughly 10%, is produced by fermentation process. Now, how do we increase the content? How do we increase the content? If the fermentation process has produced few, yes, or it's not enough, the ethanol is not enough, how do we increase the content? So, the alcohol content, what you do, the alcohol content can be increased by the alcohol content can be increased by fractional distillation of crude oil. So that is, if you want to increase the content of the ethanol that is being produced, you use fractional distillation of crude oil. Now, the ethanol produced has got water. Yes, it has some water. Yes, the alcohol obtained, yes, the ethanol produced contains water, and it is removed by a drying agent. That drying agent is calcium oxide. So calcium oxide is added to dry. It is used as a drying agent. And it's removed by a suitable drying agent. And the suitable drying agent that you use here is what? Calcium oxide. Remember calcium oxide? We have used to dry ammonia gas. Now, that is the first preparation of ethanol. What do we say? Fermentation process. Now, there are other alternatives of obtaining ethanol. Yes? And alternatively, ethene may be hydrolyzed. You take ethene gas, ethene may be hydrolyzed using concentrated corn sulfuric acid. What do we mean? Yeah, I want to obtain ethanol still, apart from fermentation process. Fermentation process, we say, is that process of yeast being added to sugar molecule. The yeast has an enzyme, it will break down into carbon dioxide and ethanol. That is fermentation process, whereby there is a decomposition of organic substance by microorganism. But alternatively, we can prepare ethanol by hydrolyzing ethene using concentrated sulfuric acid. What will happen? Ethene now, when it's hydrolyzed using concentrated sulfuric acid, what it will form is called ethyl hydrogen sulfate. So ethene is C2H4 gas. When you add concentrated sulfuric acid, H2SO4 concentrated, what you will obtain is, yes, let me write the word equation first, before the chemical equation. Ethene, when you add concentrated sulfuric acid, what you will obtain is ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Now let's write the chemical equation here. The chemical equation is ethene is C2H4 gas, concentrated sulfuric acid is H2SO4 liquid, Now, what you will obtain, how do you write ethyl hydrogen sulfate? How do you write ethyl hydrogen sulfate? Ethyl hydrogen sulfate. C2, one of the hydrogen will come here, C2H5, then the sulfuric acid will rearrange, it will become OSO3H. Remember, we had two hydrogens from sulfuric acid. So one hydrogen will combine with the ethene and it will form ethyl, then hydrogen sulfate, ethyl hydrogen sulfate. Now, when water is added, what happens next? Ethyl hydrogen sulfate now is added water. When water is added, ethyl hydrogen sulfate, what will happen? What do you do with it? You add water and the mixture, yes, and the mixture is hydrolyzed to ethanol. The mixture is hydrolyzed to ethanol. The mixture is hydrolyzed to ethanol. Now, this ethyl hydrogen sulfate, C2H5OH, H5OSO3H, ethyl hydrogen sulfate. When you add water, what you will get is the ethanol. What you will get is what? Ethanol, which is liquid, plus sulfuric acid, which is aqueous. So we have obtained ethanol in a two-step process. That's what we have been looking. Number one, we say fermentation process, ethanol is obtained. Number two, by hydrolyzing ethene using concentrated sulfuric acid. Now, still, the ethanol that is produced here is not enough. If you want on large scale now, yes, if you want large scale, a lot of ethanol, if you want to produce a lot of ethanol on a large scale, the third one now, this is number two, alternative number two. Alternative number three, on a large scale, ethanol is manufactured by reacting steam with ethene. Steam and ethene are reacted together by reacting steam with ethene at a temperature with conditions, yeah? At a temperature of 300 degrees Celsius and pressure of 60 to 70 atmosphere. 60 to 70 atmosphere over phosphoric acid, over phosphoric 5 acid, over phosphoric 5 acid. Now ethanol, if you want to produce a lot of ethanol, what you do, you take ethene, you react it with steam at a temperature of 300 degrees. So these are the conditions: temperature of 300 degrees, pressure of 60 to 70 over phosphoric acid, phosphoric 5 acid. What is the importance of the phosphoric 5 acid? That's a very common question. Very, very common. Phosphoric 5 acid is used as a catalyst. So, phosphoric 5 acid is used as a catalyst. Phosphoric 5 acid is used as a catalyst. And if you write the equation, it is very simple. Ethene, C2H4 gas. When you react with steam is just water vapor, water which in form of gaseous state. How many conditions? Phosphoric 5 acid. Phosphoric 5 acid. Temperature of 300 degrees Celsius. Pressure of 60 to 70 atmosphere. What it will produce is pure ethanol. Pure ethanol. So if you want to obtain ethanol in a large quantity, on a large scale, ethanol is obtained on a large scale by reacting steam with ethene. And with this condition, temperature of 300 degrees, pressure of 60 to 70 atmosphere, and phosphoric 5 acid, and phosphoric 5 acid, and phosphoric 5 acid. Now, that is alternative number 3. So, to summarize the lesson, we say ethanol can be prepared in 3 ways. Ethanol can be prepared in 3 ways. Number 1 is fermentation process, where the sugar molecule is added to a yeast, and then the yeast has an enzyme called zymase, and it will break down the sugar molecule into ethanol, carbon dioxide, and energy in form of ATP is produced. So by a process known as fermentation process. Fermentation process. Alternatively, ethanol, we say that fermentation process, the ethanol produced is just 10%, very little. So we go to alternative number 2, whereby ethanol can be obtained by hydrolyzing ethene gas. Remember ethene gas? Using concentrated sulfuric acid. Using concentrated sulfuric acid. Where you get ethyl hydrogen sulfate, the ethyl hydrogen sulfate is added to water, you get ethanol. Another method, if you want to obtain ethanol on a large scale, you react steam with ethene gas over phosphoric 5 acid, H3PO4, H3PO4, phosphoric 5 acid. That phosphoric 5 acid, temperature of 300 degrees Celsius and a pressure of 60 to 70 degrees, 60 to 70 atmosphere, 60 to 70 atmosphere. With those conditions, you will obtain ethanol in a large quantities. So that's the end of the lesson. For today's lesson, that's the end. 3 methods of preparing ethanol. And in our next lesson, we shall be discussing about physical and the chemical properties of alkanols, physical and the chemical properties. And that is where it is tested in paper 2. Most of the questions comes from the the chemical properties of organic compounds. Thank you so much. Stay at home. Be safe. Yes, we shall talk about physical properties next lesson, inshallah.